Okay, hi class. Thank you for joining us today on this podcast. And I know from my recent visit to your classroom, you're a great group of really clever primary school pupils. You had no problem estimating cost and carbon emissions from the different light bulbs, and you mastered your use of spreadsheets. Today, we're joined by Professor Ivan Haigh, and he's a leading expert on sea level rise and coastal change, who's kindly agreed to answer your questions. So, Ivan, these pupils have been learning all about coasts, climate change, and the challenges our shoreline faces. So, can I hand over to you?
Yeah. Hi, everyone. It's such a pleasure to be with you. I have been very lucky and on a number of occasions gone into the Houses of Parliament and spoken to MPs, but I'd much rather be speaking to you. So I've been into quite a few schools and I love it. So yeah, really looking forward to speaking to you and answering your questions.
Thank you. Right, our first question, I think, is Max. How long will the sea level be rising?
I'm going to share my screen. Can you see my screen?
Yes, I can see your screen.
Okay. Just before I answer your question, is that your school?
Yeah.
It looks like a very, very nice school. So what I thought I would do first of all is who knows what AI stands for?
Artificial intelligence.
Very, very good. Well, what I did is I asked ChatGPT to see what your school looks like underwater, and that's the photo I got. Well, the image I got. So I quite like the reflection of the logo there, but we'll come on to that question a bit later. How long has sea level been rising? Well, sea level has changed a lot throughout history. And the first thing we're going to do is we're going to go back 24,000 years. Are any of you 24,000 years old? Are any of your mums and dads 24,000 years old or your grandparents?
Great, 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 that's great. Yeah, probably me too.
Yes, exactly. So we go back 24,000 years ago. So on the left here, I don't know if you can see my mouse, sea levels were actually 120 meters lower than they were today. So I don't know who's the tallest in your class, but let's say you're about 1.5 meters high. Imagine that 120 of you sort of standing on top of each other. Sea levels were much lower than they were today. And that was because of the last ice age. So most of the United Kingdom was covered in ice. And in fact, we can have a look at a map here. So can you see the UK here? There's Wales. Can you see my mouse?
Yeah, they're very black. The black. Oh, yeah, yeah.
Let me just see if I can put a pointer on to be a bit more clear. But yeah, so you can see the UK there, and that grey is what was ice. So all of the north part of the UK was covered in ice. Okay, so yeah, the north of Scotland was covered in ice, and all of Wales, you could see actually there was no Bristol Channel. That was all land. And in fact, the UK was connected to Europe. Can you see here? That was all land. And this blue is where sea level, well, I'm going to go back one actually, 20,000 years ago. There wasn't even an Irish Sea. But if we skip forward to 15,000 years, sea levels began to rise as that ice melt. And can you see it form the Irish Sea? If we go forward to 12,000 years, can you see it starting to form the English Channel? And even then, Barry Island would have been a long way away from the coast. And it's only around 9,000 years ago that Barry Island would have been closer to the coast. And you can see this was the first time that the UK was an island. And then we go to 7,000 years ago, and sea levels have been very, very similar since then. So actually, sea levels have changed a lot, more than 120 meters. But what, as a scientist, we're worried about is that over the last 2,000 years in particular, over the last 8,000 years, can you see on the top here, sea levels have been very stable, similar to what they are today. And sea levels sort of stopped rising as that ice melted. But what has happened over the last 150 years is we've had global warming. So we had the Industrial Revolution. Hopefully, you all know about that. We started emitting lots of carbon dioxide into the atmosphere. and the planet began to warm. And this is the warming stripes. Have any of you seen this image before? So on the left, we have, down the bottom, we have 1850 all the way through to today. So that's 170 years. And each bar is the temperature. Blue is when it was cooler, red is when it was warmer. And temperatures go up and up. Some years are warmer, they go down, some years are cooler. But what you can see is since 1970, as we built more cities, as the population have increased, sea levels have just, temperature has warmed and warmed and warmed. And 90% of that temperature has gone into the ocean. This is when my grandfather and grandmother were born in around the 1910s. And actually, England was in a very cold period, and people in London actually remember the River Thames freezing. My mum and dad were born around 1939. Does anyone know what happened in 1939? Miss Weaver? Miss Weaver, did you want to pick someone to answer that?
Yeah, EVD. The second.
Yeah, so my dad was born at the beginning of the Second World War, and my mum was born at the end. And then both my wife and I were born in 1979, and my daughter was born in 2012. So my daughter's 13. How old are you? 11. So you were born here when just things were really, really starting to get hot. Now, what we can do is, what was the impact of that on sea level? Well, remember what I said before, sea levels were stable for about 8,000 years, but this shows 220 years. So going back all the way to 1800 here. Barry Island was probably an island back then. And these are 4 long tide gauge records. So these measure how fast sea levels are rising. And sea levels go up and down. So Brest is a very long record in France. Amsterdam is in the Netherlands. This is a site in Poland. Where are Boston and New York? Which country are they in?
America.
America, yep. But what you can see is for all of these tide gauges, sea levels were relatively stable, but around 130 years ago, sea levels have begun to rise, and they've risen by about 30 centimeters. So at all of these sites, you can see sea levels have begun to risen. So just very quickly, sea levels were much lower than they were today, or much higher than they were during the Ice Age. But as a result of climate change, around 1880, sea levels began to rise. And since then, that rate has just got faster and faster. And we've seen about 30 centimeters of sea level rise. And over the next 100 years, we expect sea level rise to be at least a meter, maybe more.
Great. Thank you so much. Right, our second question then, if you're ready to move on.
Will the sea ever cover Barry or our school?
What do you think?
Yeah.
Maybe
Put up
more.
your hands. Put up your hands if you think your school is safe and sea level rise won't reach your school. And put up your hands if you think sea level will reach your school. Okay, well, let's have a look. So, am I right in thinking that your school is here on the map? Now, where do you all live? Do you live on the island, or do you live off the island?
On the island or just off of the island? By the
Okay.
docks there.
Okay, so this is a website called Climate Central, and if you ask your teacher, I'm sure she could show it you and you can actually play with the website. But if you go to Climate Central website, there's a tool that allows you to look at which lands might be at risk of flooding. And on the left here is a little bar, and at the moment it's 0 meters. So this is what it looks like today. So today it's only really the very front of Barry Island that experiences a little bit of flooding. But let's see what happens. If we go up 1 meter, that's what happens. So I'll go back and up. So you can see we get a bit more flooding in the docks. And that's what we sort of expect to see by 2100. So if you are 10 now, you'll be about 90. It is possible that sea levels could be as high as 2 meters, although that's unlikely. So you can see that actually Barry Island is quite high. So I think your school is safe. If we go up to 3 meters, you can start to see there's a bit of low area there. Maybe you could actually even go down and walk there and have a look, but there's a bit of a low area there. if we go to 4 meters, so actually Barry Island, I think, is relatively safe from sea level rise. But if there is a major collapse of ice sheets, I don't think this is going to happen in the next 100 years. But you can see, so your school is actually very quite high up. At this point, Barry Island would be go back to being an island. 5 meters. Do any of you play in Maslin Park? I don't know how to pronounce it.
That's right, yeah.
Yep, you'll still be able to play there, but if sea level is 10 meters, that's very, very unlikely. But if sea level is 10 meters, your school will still be safe, but the park will go, so you won't have anywhere to play. So I think actually your school is relatively safe, but you can see some parts of Barry are quite low lying.
Okay, great. Thank you so much. And number 3, original.
What would happen if all the ice in the world melted?
Well, we have 3 main sources of ice. The first type of ice is glaciers, and I'll show you a picture in a minute, but if all the glaciers in the world melted, and most of them are melting, we would get about half a meter of sea level rise. But the other 2 really big areas of ice are Greenland and Antarctica. Now, Greenland is very big. It's almost 3 kilometers of ice. So how much do you think, if all of Greenland was to melt, how much would that rise sea level?
0.3 meters.
It's
0.3 meters.
It's actually 7 meters. So if all of Greenland was to melt, the whole ocean would rise by 7 meters. So that is like double the height of your classroom. Now, Antarctica is even bigger. If all of Antarctica was melt, we would get 60 meters. So if all of the ice in the world melted, it would be 67 meters. Now, that's very, very, very unlikely, and it would take thousands of years. But this is what the UK would look like. So Barry Island is down here somewhere. And you can see that, yeah, all of Barry Island would be underwater, but you can see all of London would be underwater, all of sort of the Norfolk region, a lot of area around sort of York, Liverpool, Chester. So that's what the UK would look like, what Wales would look like if it was all of the ice was to melt. Now, we are seeing quite a lot of ice melt. So this is a glacier in Norway, or a glacier in Norway. And this is what the glacier looked like 130 years ago today. And you can see, have a look at this rock in the front. Have a look at where that person, and can you see the ice comes right down to the ocean, or the lake, sorry. And this is a photo 15 years ago. And can you see a lot of that ice has melted? So can you see the same rock? A person is sitting in the same place. Ren, do you want to come and say hi to the school quickly? Come and say hi. This is my daughter. So she's so you can see that the ice is melting. Now, we think that, yeah, Greenland and Antarctica are so big that it would take hundreds and hundreds of years to melt. I hope that answered your question.
Yeah, perfect. Thank you. All right, number 4 then.
Can we stop the sea from rising?
Okay, so we, as I said at the start, we're putting lots of carbon dioxide into the atmosphere. We're burning fossil fuels, coal. We are concreting lots of areas up. We're cutting down lots of trees, and we really, really need to stop that. And if we can stop that, then some of the negative consequences of climate change will slow down. But the problem is sea level is different. We've only warmed the surface of the ocean, and that heat takes hundreds of years to go down into the deep ocean. And we've started melting Antarctica and Greenland, and it's easier to melt ice than it is to make ice. So even if we went into negative emissions, sea levels are always going to continue to rise for hundreds of years. It's sort of like if you cook an egg and take your frying pan off, it still continues to cook, a bit like a cake. So this is some work we did where we're looking at sea level from the year 2000 all the way out to 2300. If we're able to keep temperature to about 1.5 degrees or 2 degrees, that's the grey and the blue, sea levels will continue to rise because that heat will transfer down into the ocean. But if we carry on warming at the rate we're currently warming, you can see that we could have up to 4 meters of sea level rise by 2300. So your kids. So it's going to be almost impossible to stop sea level rise, but we can slow sea level rise down. And these are some of the things that my family is doing to slow sea level rise down. So this is my daughter. So we are trying not to drive very much. We try and either cycle or walk whenever we can. I cycle to work every day instead of driving. We have insulated our house here. We try not to buy any new furniture. We try and get things secondhand. This is a cupboard we got secondhand, and my wife sort of painted it up. I try not to travel so much. I try to do video conferences. So instead of coming to your school, we've done it over the video. We've put in energy saving light bulbs. We try and eat food that's also in season rather than out of season, so that it doesn't have to be shipped from around the world. So those are some of the things we're doing, and I very much hope you can encourage your brothers and sisters and your mum and dad also to try not to emit as much carbon. So we're not going to be able to slow sea level rise down. We're not going to stop sea level, but hopefully we can slow it down. Thank you for that question.
Amazing. And I think we've got one final question left.
How could I become a climate scientist?
Well, I very much hope you all become climate scientists. I didn't really know what I wanted to do at school, but I went to university and did oceanography. I just loved the ocean and loved the coast. And I've been working now as a climate scientist and oceanographer for the last sort of 24 years, and I love it. I would say the most important thing is to be curious, really be interested in the world around you. You live in a beautiful country, Wales, you live in a beautiful place near the coast. You know, go down and have a look at the sea. Be really kind of curious about how weather works, how clouds works. Explore. Try and, I don't know, do any of you have phones yet?
Yeah.
Put away your phones, leave your phones at home, get out into the woods, go and explore, go down to the beach, really get involved in kind of looking at nature. By far the most important thing is to ask lots of questions. So really get your teacher annoyed, ask her lots and lots of questions about the climate, about the weather, about the ocean. Read and watch documentaries. There's lots of good information. There's lots of good resources about the climate and the ocean online. I think being a scientist, you have to be creative. There's a lot of problems in the world, and you have to really think, how could we solve those problems? So really practice being creative. Who knows what this word means? Collaboration.
Collaboration is like teamwork, basically.
Yeah, that's very good. If you want to be a climate scientist, you've really got to learn how to work in teams. The problem is so big, we can't solve it on its own. So climate scientists involve people that look at weather, people that look at the ocean like me, people that understand the land. So you really need to learn how to kind of collaborate. So those are some of the things, and work really hard. And yep, I hope in 20 years' time, I'll see some of you are climate scientists, and you must get back in contact with me and email me to say that you've become a climate scientist. I'd love to hear from you. Okay, thank you very much.
So thank you.
Thank you.
Brilliant. I think that brings us to the end of our questions and answers. I want to say a huge thank you to Professor Ivan Haigh for sharing your time and expertise with us today. And thank you for the brilliant questions. So hopefully we'll see you all soon. Bye, everyone.
Thank you, everyone. Bye.